Okay, we're back again. I'm gonna sit here so everybody on the live stream is gonna see me as well. To reiterate, we have some prizes, questions automatically get in the drawing box, and you can win some cool desk pads or some books or some headsets. Okay, we're back with the second presentation from today's talks. It will be about building the architecture of a test pyramid strategy. Catalin Tudose, author at Pluralsight and Manning, Java and Web Technologies Expert at Pluralsight Romania, we're gonna introduce and tell us how to do it. Please.
Hello everybody, thanks for the introduction. Welcome to my talk. It is about software testing and about how to build the architecture in a pyramidal style. You'll see what it means. About testing, you may be familiar with it. Just to remind that testing software means to make some objective judgments if it meets its expectations or if it fails to meet that expectations. But testing is very detailed, and we may talk about types of testing. You may test at the level of some units. You have some individual classes and methods that you are going to test, and you will see if they work in isolation. This is the first type of testing. Integration testing. Here we put together packages eventually elaborated by different teams, and we would like also to see that they work together, but this time we are not only looking for individual behavior, but by the interaction. They need to integrate well. System testing. System testing means you will see the system as a whole. And if you depend on some outside resources, for example, some outside devices, some outside database, you will need to test in the presence of this outside resource or the outside device. But until then, you would like to take care of testing independently of those outside conditions. And finally, acceptance testing. You would like to know if your system is suitable for the end user, if it fulfills the needs of the end user. Because you may have a system that is doing a lot of things, and however, it may not be so useful for the user. Acceptance will tell you if it's fine from this point of view. You see here, these things are aligned this way, but we will switch to this view where we'll have the test pyramid, because we're saying we are looking at the test pyramid. You may see some variations of this pyramid in different works by different authors. This is the one that I adopted because I considered the most appropriate. I used it in my work, including my books and my online courses. You see here at the ground, from unit testing, integration testing, system testing, at the top, acceptance testing. If, like in a pyramid, if you have a good ground, if you have strong first levels, it will be easier for you to build on top of them. But of course, the goal is to build the whole pyramid. What to do with Java, what to use in order to test in a pyramid style. Which tools, which frameworks, which environments to use. For unit testing, you may be familiar with JUnit, now arrived at version 5, eventually with TestNG. They are popular frameworks and they are in use everywhere, especially JUnit. For integration testing, the most popular frameworks are Quillian and Spring. We may test for integration with both of them. And we'll demonstrate a little later how to do this in a practical style. For the system testing, until your whole system is running and functional, you may need to mock those parts that are not under your control. I was talking about external devices, I was talking about external databases that come with data. For some good part of your development time, you may choose to mock those parts. What for? In general, you would like to test your code, you would like to test your application independently of external resources, independent of external influence. Sometimes you don't know what those external devices do. Sometimes it is really hard to set up them. For example, if you would like to test on a database, you will have to set up the server, you will have to populate the database, and you will have to make sure that the database will remain with the same content for the period of the testing, because you will ask for some records and you will test on them, your business logic. And if this changes, your tests will be broken. And for a good period of the development, you may choose to mock that database. Or for example, you would like to test the behavior that is influenced by some external device. Let's say that we have a sensor that is triggered when we have 0 degrees Celsius. We cannot have always 0 degrees Celsius, so we may mock that external device. And we focus on testing our code independently of the external influences and of the external devices. And finally, for the acceptance testing, we have a few tools to mention here: Cucumber, JBehave, Selenium for web applications. Probably nowadays Cucumber is raising, and you may find it more and more used. I encounter it more and more used in different projects. Just to mention, JBehave is really popular also because it was the first framework of this kind. It was developed when the concepts of behavior-driven development were introduced, and it was developed exactly by the one that invented this behavior-driven development, Dan North. So you may have a few alternatives, but they all follow some common philosophy. Why should you test at the unit level? For a very good few reasons. Your code will be safer. You will find bugs early, because if you test, you run automatically the tests, you will find early if something is wrong, or if you introduce something in your application and it breaks something that is already there. That will help you finding bugs early. The unit test will act as safety net. You execute a unit test and you find out that some test is failing. That will immediately tell you where this happens, which piece of code is failing, so we may say you are going to isolate incorrect code. You'll introduce new functionality easily, because if you rely on the previously written tests, you will make sure that you will not break anything, you're not introducing regressions. If you are looking forward for your new functionality, you may go test-driven or behavior-driven. This will mean that you will be driven by the test or by the behavior of the application, and you will focus to write that piece of code that will satisfy the test, that will make the test pass, or in the case of a behavior-driven development, that will satisfy the user's needs. So you are driven by these tests. We may introduce new functionality easier. And last but not least, it documents the application, because you may know how tedious it is to write documentation. It is necessary new people join the team, they want to know what's happening, you would like to be reminded about what you did, you would like to know what your colleague did, and it's really tedious. But if you write tests, these tests will be effectively part of your application. Because if you will run tests, you will quickly see how your application behaves, and those tests will be effective part of the documentation. And I will move here. I have some pieces of code just to quickly present and focus on some small application that is isolating these ideas. Here, unit test, if we have this small application that is having the classes flight and passenger, unit test, in our case with the help of JUnit, will mean that we'll test our classes in isolation. So everything from here is tested in isolation of the other classes or other packages. We have a test that is focusing on the flight, we have a test that is focusing on the passenger. Of course, this will not be enough, but if we don't have this part at the ground already functional, why should we go further? This is the basis of our pyramid. About integration testing. This time it means that you have your units combined and tested as a group. You have to check the interaction between these integration units. Maybe those parts of your application are not providing the good interfaces in order to interact with the other parts. So we may say that we are exposing defects in the interfaces. Let's give here a very good example right from JUnit. JUnit changed its architecture from JUnit 4 to JUnit 5 for a few reasons. One of the reasons was that its interface was not good enough to work with external tools, with IDEs, with build tools. So it was very popular, JUnit, but it lacked this interface to interact with whichever software was using it. And to talk about integration testing types, black box testing is that type when you just care about what's input and what's output. You don't know anything about what's inside. White box testing means that you see all the internals and you care about them. In most cases, you are going to use some mixed type of testing here. Gray box testing, you care about some of the internals, but not about all of them. Pure testers will use a black box testing because you know that they write some test cases and they say, I have this input, I am expecting this output, I don't care about what's inside, this is the developer's business. We may decide to perform some integration testing at some time without deploying to the application server. We can use the test against some container, and we may use here Herculean Spring Test on text, just to provide you a taste of what this means. I have here, so I am thinking about testing these classes, but no longer in isolation. They need to interact with each other. The previously written tests, flight test and passenger test, the unit tests, are still here. We introduced here this Herculean dependency, which I was saying it is a very good tool for integration testing. And as I was saying, we would like to test without deploying to the application server, but we are using some Herculean archive built on the fly, while creating this test, and it will put together these classes that need to be tested, and will test them integrated, communicating with each other, just to prove that we are really running some good tests and this application is really functional. We use here Herculean together with CDI, context and develop and dependency injections, which is part of Java Enterprise Edition. But as I was saying, there are some other possibilities, for example, to work with Spring Test context. And we move now to the idea of system testing. So I was saying that we have a system under test. It is our software, and we would like to test it. We are concerning only about our work, but we have to deal with some external dependencies, what we call here dependent on components or DOC. We are depending on it. However, we would like to test only our application. What can we do here? So we talk about contract testing. So we say we have to make some contract that whatever software is coming from that side has to have this functionality. And if you are interested about what I'm doing here, we also have to know the specifications about what my software will provide. However, you are implementing in your team this philosophy, this application is your business. You just have to follow the contract until we are ready with both our parts. We may use those test doubles, and you may use test doubles for development for weeks or months. At some time, you may say, okay, let's now test against the real system, because we think we are fine, but of course we have to arrive to the real usage of the system before sending it to full production. I have to test it in real conditions, and I will remove those test doubles and I will test against the real system with these conditions, that if all parts have followed their contract, consumer provider driven contract, it will mean that we may have a successful application. So this contract testing may mean that if we have consumer and provider on the two sides of the contract, the consumer may be developed with a mock provider until we arrive to the full application, and the provider will be able to be developed and tested with a mock consumer until we arrive to put everything together. As long as we are following and respecting our contract, this may be a successful thing. Let's show here something. What I'm meaning here, I'm presuming that some other part of the team, some other team, has to take care of this distances manager. This is a simple example just to focus on the idea. And you see, we don't know what it is doing yet. They are working. Let's say that we have a very complicated business logic, not just a class, but they are working on it. But we know about the interface, we know about the contract, we know about what needs to be implemented, how these methods should behave, which is the functionality that must be provided to our part of the work. And here I will say, okay, let me mock this distances manager, yes, so that you do your work on your side and I can do my work on my side, unaware of the implementation of this distances manager, but I may say, okay, whenever I'm calling this, I'm expecting something. I'm mocking this distances manager, and I'm just saying I know the contract, I know what to expect from it, but I don't need, or the implementation is not yet available. And the work may continue, and at some time, let's say that the other team advanced, they implemented a good part of the work. This is still not implemented, but let's say that this is working. What can we do in order to align with what has already been implemented? We are going here to use a spy. So you see, our previous test was fully mocking this distances manager. Fully mocking the distances manager, or fully mocking one object, will mean that unless we instruct it what to do, it will have no behavior. While here, on spy, will mean, okay, I know that I can use some already implemented part of this distances manager, and I remind you that this part is already implemented. But as I'm not expecting everything to be implemented, I will say I still instruct you about this. And the other functionality that is there is effectively executed. If that will be a mock, then it will not care if something from here is implemented. It will say, okay, it is a mock, so this will return null, this will return null, this will not do anything because it is void. Let's see that we are still on the right way. So we have these units, and we have this integration and system tests. And you may decide at some time, okay, the other side has fulfilled its work, and this other part is fully implemented. So now I can, this last part that was not implemented is now functional, and now I can decide, let me use the full application here. So you see, no mock, no spy, I'm just injecting that object. And I'm testing here. Let's see that we are really going fine. We are testing the whole system, but not from the beginning. We are decoupled, and we may integrate the parts of the system little by little, following that contract. So let's review this. So as long as we are following, we may mock the provider on the side of the consumer, we may mock the consumer on the side of the provider during the development. And the last part of the pyramid, the top of the pyramid, is the acceptance testing. I was saying that we need to evaluate that system with the business requirements if the system satisfies the end user. We can introduce some new features with Cucumber. I was saying that Cucumber is one of the frameworks that is used in acceptance testing and behavior-driven development testing. And what is really nice from the point of view of these automated acceptance tests is that they can be read just like stories, in plain English, in plain Romanian, in plain whatever language you would like to, as long as you use these keywords from here, feature scenario given when the and. So these are the parts of the test that looks like an automated acceptance test. Let's switch to the last implemented here acceptance testing. You see how our acceptance testing tests are looking like written with Cucumber. You may immediately read them and you may immediately understand what it is about and what it is expected from that application. So all stakeholders may have a look at these acceptance tests. I was saying that tests also may work as part of the documentation of the application. And any stakeholder, even if some stakeholder is a less technical one, will understand what it is about, what it is expected from that application. I press this button, I introduce this, and I'm expecting this, and I can express this in these scenarios. What it is nice is that these scenarios translate here in some Cucumber tests. You see that this given, when, then are Cucumber annotations, and you may associate each step from here with a method from here. And you may ask yourself, what does it mean that given there is a flight, whatever, and seats defined into? It will mean, translated into code, this piece of code. What does it mean that you do an action of this? It will mean this piece of code, and so on. So you are going to translate the steps of your scenarios into Java code. You say, I have this, I do this, and I'm expecting this, and this is part of the automated acceptance test. Okay, we arrived at the top of the pyramid and we still have some bad news. Even if we cover everything with code, with tests, 100 code coverage, even if we arrive to that 100 code coverage, which is really unlikely in a real application, will not mean that your code works perfectly. Because the quality of your tests is unknown. There is still some type of testing. I cannot classify it at in that pyramid, but it is worth to be mentioned. It is called mutation testing. What's the concept of this mutation testing? The mutation testing will say, okay, we have these tests. Okay, they work fine, great. What's your, you run those tests, everything is green. A library that is, or a framework that is relying on the concept of mutation testing will say, I will try to execute again this test, but on a modified code. So mutation testing framework like it is called PyTest, for example, you may find it is there, will go and modify your bytecode. And for example, if we have here an if, it will change the bytecode so that you will have the opposite condition. And it will say, if your tests are really good, then your test now against the modified code will fail. So that will be a real measure of the quality of our tests. But this comes somehow outside the pyramid. At the level of the pyramid, we ensure that first we have a very good ground on which we can sit. Saying thank you, I will just invite you, if you would like to follow me, you can follow me here on LinkedIn. I chose here to directly present this. Somebody added me, I think, during this presentation because this was not here. So I'm on Twitter and on LinkedIn. This is the book that I wrote at Manning. You see here November 2020. Generative in Action is about testing. From the ground to the top end, there is a special chapter dedicated exactly to this testing parameter. And also, I was saying that I'm an author at Pluralsight. I have a few courses on testing, and one of them is this one, implementing a test parameter strategy in Java. So, saying again, thank you. I'm looking forward for your questions.
Thank you, Catalin. We'll take questions now. We're going to start with him because he was the first hand up.
So how about tests that generate costs, like load testing and stress testing, that are for better results, you make them against real systems?
Yes.
It costs money, and
Yes. So
the company should.
You are raising here a real problem. Exists. You have a system and you would like to test it under some stress conditions, right? Load test or performance test. They will tell you something about how your application works in these stress conditions. However, I will not classify them here in this parameter. So I will.
Functional testing.
Yes.
Yes, this is functional testing.
Yes. So I was saying even earlier, I was saying we have mutation testing, which is really important. It ensures us about the quality of our tests. But I wouldn't classify it in such a parameter.
Pyramid is for functional.
Parameter is saying, let's make sure that our units are working well. Let's say that they integrate. Let's say that I can talk with an external system. Let's see that we are doing the right thing to satisfy
Stress testing and
the
load
user.
testing is different.
Stress testing, load testing, mutation testing are very good examples of needed types of testing, but they should be classified outside this parameter.
Thank you.
Another question here.
And then we'll come to you.
What do you recommend between Cucumber and Selenium from a maintenance perspective?
It depends on your application, because Selenium is very good to test some web interface, while Cucumber will test some standalone code. So it depends on what your application looks like. Both are good, very good, but it really depends on the nature of your application.
Okay, yes.
The same. Okay, the same. Okay. Other questions? Okay. Everyone.
So my question is about if we should try to reach 100% coverage, because in my experience we ended up having too much testing code, and it became more and more annoying to even read it. So if we shouldn't pick up the battles and try to make like the regular code, try to make it more maintainable, and maybe
So
the less the better.
in general, you cannot reach, even if you strive for it, you cannot reach 100%. In my practical experience, I would say that many projects have inside their definition of done as condition to have a code coverage at least 80%. This is in general doable. The step between 80% and 90% is harder. Sometimes you need to do some artifices to do a few things. You may think if it is worth to invest time and to have those more and more tests that we were talking about. This is pretty common question about how high we can arrive with our code coverage. I was saying even 100% code coverage does not mean your code works perfectly. And in one of my courses here, I think it was just like TDD with steering time, I was discussing exactly something about this percentage. It shouldn't become an obsession. High code coverage like 80, 85 plus is good, but it does not guarantee that you are bug free, and it should not become tedious and cumbersome. You should strive for the quality of your tests as well. Thanks.
Actually, you've already answered the question. I have the same question as him, but I can try another one. So, in the last couple of years, we've seen a rise in, actually a switch from synchronous APIs to reactive programming, reactive streams, even event-driven architectures. What are the pitfalls in testing such systems?
So the pitfalls in testing such systems may be that they are non-deterministic. So you may not guarantee how the sequence of operation is executed. This is just like working with asynchronous code, because you're expecting something at some time, but you don't know when that will happen. I think that the testing of asynchronous and reactive programs will go hand to hand with the development of these solutions. If they will be the good solution, we'll see. Because I have recently followed some talk by Brian Gibbs. He was expressing his ideas that reactive programming will not be the solution on the long term, and at some time people will see that they do not come with so many advantages compared to the pitfalls. We'll see how this evolves, because it is the future and the market and the developers themselves that may tell us if we should go this way or should go this way.
Thanks.
Awesome. I guess there are no more questions, so thank you very much for your presentation. A round of applause. And I guess this concludes our Talks by Softinator edition today. Thank you again for our presentation. We have some goodies. We have some people that ask questions. If there are more goodies at the end than people that ask questions, you can maybe check in on the event and we'll include you as well. But you're gonna handle it. Anyway, in 2 weeks again, we won't have a Talks by Softinator because there's the international coming up, the Dota Championship, the international. But we'll see you again in a month. Hopefully physically here in Mojo again, if not online. Thank you all for coming here and enjoy the networking and build afterwards. We're gonna extract it after the live is done, so we're gonna do it afterwards. Okay, thank you everyone, and see you soon. Ok. Câte bilete avem? Câte premii avem?
Păi nu știu, 2, 3, 4, 2 cărți, 6 premii și 70. Dar nu e mai trage, ea le trage de